Hello, I'm Yuri Belsky. Today we will learn the heuristic of situation analysis. This heuristic can help a novice to analyze situations more thoroughly and to acquire advanced skills in problem analysis and problem finding. I am certain that you have experienced situations when the problems you were trying to resolve changed their appearance. When these problems were resolved, they looked very different to what you perceived them to be originally. Such problem metamorphosis is well known to expert engineers. We start solving one problem as it is formulated, but when we get more information on it, we discover that what needs resolution is entirely different. In order not to waste time and effort, these experts often utilize the owl's wisdom. They try to analyze and frame problems, or as they say, find problems, by answering a set of questions. I have used a set of 11 questions for that purpose, and will share these 11 questions of the situation analysis heuristic with you in this lesson. In essence, the situation analysis heuristic helps a user, firstly, in identifying different problems embedded in the situation, and, as you may already know, every technical problem contains numerous sub-problems. Secondly, the situation analysis heuristic helps in separating technical challenges from the human-related challenges. Every expert engineer knows well, most problems that initially appear very technical usually contain human-related challenges. And eliminating these human-related challenges could result in partial and even complete disappearance of the original technical problem. Thirdly, the situation analysis heuristic can help in formulating the tasks to be undertaken for the situation improvement. When a list of such tasks to solve is created, it is recommended to approach these tasks in order of priority, and, if possible, to address the tasks that contain human-related challenges first. Prior to learning the heuristic, we need to agree on some definitions. First of all, we will use the word system for a set of components that, as a result of putting them together, fulfill a function that neither of the components was able to fulfill on its own. The road train, shown in the picture, is an example of a system that, among other components, contains a powerful truck tractor unit and 3 semi-trailers. The main useful function of the road train is to deliver cargo. The supersystem or the superior system of the road train is the transportation system. Having clarified these definitions, we are ready to learn the situation analysis heuristic now. In order to introduce the situation analysis heuristic, we will use a real story that occurred a few years ago at one of the factories that manufactured and packaged hospital infusion kits. One of the factory engineers who had just learned these heuristics had to apply these heuristics to a real company project. I helped the engineer to apply the heuristics correctly. Therefore, he regularly provided me with reports on his thoughts and his progress, as well as asked me questions regarding the application of heuristics. The project dealt with the hospital infusion kits that had already been hermetically packaged into plastic bags and were sterilized. The project was originally formulated as elimination of foreign particles from the infusion kit bags. Situation analysis was the first heuristic used by the engineer. Let us follow his thoughts and reflections. The first question of the situation analysis heuristic required the engineer to reflect on the problematic situation. One of the new customers, let us call it customer A, returned around 4% of the kits that the factory shipped to the customer. Returning the bags, customer A claimed that some of the hermetically enclosed kit bags contained foreign particles. Furthermore, these particles were identified by customer A with red circles that were drawn on the surface of the bags. At first, factory workers at the production plant that were responsible for visual inspection of the sealed kit bags prior to shipment were unable to find any foreign particles inside the red circles. These particles only became visible when they deployed a magnifying glass 5 times the magnification of that they used for the final inspection that occurred just prior to shipment. Also, out of 4 major customers that the factory shipped these infusion kits to, only Company A sent kits back to the factory. The other 3 customers that had been buying these kits from the factory for many years had never returned any kit back. You can imagine that the factory did its best to ensure that the bags did not contain foreign particles. They even deployed static electricity to ensure that all plastic dust that is the most difficult to remove would be eliminated from packaged bags. After the first complaints from Company A, they added a second visual inspection of the bags after sterilization. Unfortunately, those actions did not change much. Company A continued returning 4% of kits back. Establishing the system's names was simple. The engineer put it down as a cleaning process. The main useful function of the cleaning process was also obvious: to remove all the foreign particles from the bag before it is sealed. The engineer suggested the following 2 criteria to evaluate improvements in the cleaning process. Firstly, he thought about the percentage of infusion kits returned to the factory from customers, and secondly, he thought about the percentage of rejects as a result of in-house visual inspections. Also, he decided that the super system role was played by the packaging process. The first shock was experienced by the engineer when he tried to answer the 6th question. He realized that a successful packaging process cannot remove all foreign particles. He understood that some very tiny particles will always be present in the sealed bag. For example, a bacterium that has been killed during sterilization cannot be removed, as the bag had already been sealed, and such dead bacterium will become a foreign particle. It will be extremely small in size, but nonetheless it will be a foreign particle in the bag. Therefore, the ability to locate tiny particles really depends on the strength of the magnifying glass. So, it became clear to the engineer that Company A was able to identify foreign particles that were not visible to their own inspectors only because Company A used stronger magnification during their inspections. He also realized that if Company A further increased the magnification, they would likely to reject more than 4% of kits. The next question provided an unexpected hint. Question 7 asked whether the situation with Company A could be resolved without improving the cleaning process. The engineer realized that the situation would be significantly simplified if the factory agreed with their clients on the maximum size and the maximum count of foreign particles that can be permitted to be in the bag. This realization sounds somewhat revolutionary, and the engineer was unsure whether such specification on acceptable size and count of particles could be established. So, the engineer continued working his way through the remaining questions. Question 8 helped the engineer to clarify the actual customer needs for clean infusion kits. Evidently, only foreign objects that can jeopardize a patient's health must be removed from the bag. Smaller particles that are safe for the hospital patients and do not endanger their lives can be present in the bag. Reflecting on question 8 further, the engineer recalled that they only had returns from Company A. The other customers, whom the factory supplied the kits to for many years, had never returned the kit back and had never notified the factory of any hospital emergencies or incidents linked to the infusion kits they supplied. This meant that the factory cleaning process was adequate and that it removed all the dangerous foreign particles from the bags. The answer to question 9 was straightforward. The factory could negotiate with company A and convince the customer to accept packages with a certain number and size of particles present in a sealed bag. The engineer was now certain that it was possible to establish the maximum size and the maximum count of foreign particles that would not endanger patients' health. Question 10 returned the engineer back to the goal of his project. This time the engineer reformulated his goal to have 0 rejected packages from customers. You may recall that originally his task sounded quite different. He had to find ways to eliminate all foreign particles from the packaged kits. Do you see that there is a giant difference between these two tasks? The original task of elimination of foreign particles was technical. It required improvement of the cleaning process. The newly formulated task of having 0 kits returned from customers did not look technical anymore. Actually, it represented a human-related challenge. When the engineer reached the last question of the situation analysis heuristic, he saw the main task to resolve the situation as non-technical. It was entirely clear to the engineer that reaching the agreement with the customers on the maximum size and the maximum count of foreign particles that could be enclosed by the packaged kit was the first priority. Although the engineer was practically certain that the current cleaning procedure was adequate, he envisaged the possible development of a detection system that could identify the particles that exceeded the allowed size. Also, he decided to put a provision in place on future improvement of the cleaning process if such improvement would be necessary. Well, I hope that the infusion kit story demonstrated to you the importance of structured analysis of any problematic situation that you will face in the future. In the case of the hospital infusion kits problem, you have seen how the 11 questions of the situation analysis heuristic guided the engineer to the realization that in order to rectify the situation he needed to focus on a human problem, but not on a technical one. You may disagree and say that if he were able to further improve the cleaning process and the factory visual inspection was carried out with magnifying glasses of the same strength as that used by company A, he could have solved the problem too. Oh yes, he would have solved the problem until a new customer used an even stronger magnification tool to check the bags that were shipped by the factory. Clearly, the found problem of establishing specifications resolved the situation on a more general level than the improvement of the cleaning process. Let us summarize. Do not rush solving the problem when you get it. Try to find what really needs resolution. Use the 11 questions of the situation analysis heuristic and answer all the questions carefully. Be aware that the situation analysis heuristic engages a user in a non-linear process. You might be required to consult with your colleagues or customers to answer some of these questions. It is even possible that an answer to a question will send you back to an earlier question. Do not be surprised that on some occasions it may take you a few weeks to adequately answer these 11 questions and to find some unexpected problem that is hidden in the situation under improvement. It is recommended to think of the ways you could use to solve every task you list as a result of the application of the situation analysis heuristic. Always start with the task resolving which is likely to improve the situation the most. Do not be worried if such a task will require you to address human challenges, but not technical issues. Every technical problem contains human-related challenges. And after resolving human challenges, the technical part of the problem may have a very simple solution. Please visit the trees repository at Edisons21.com to download other educational material on the situation analysis heuristic and also to learn more thinking heuristics. Thank you.